Hey everyone, this is Jim, your host of Simple Christianity, here with episode 5. We're going to talk about whether things can come into existence out of nothing uncaused. In episode 2, we discussed the Kalam cosmological argument, where it states it's a logical argument stating, number 1, that everything that begins to exist has a cause. Number 2, the universe began to exist. And then number 3, therefore, the universe has a cause. And then that cause is God. In that episode, we discussed some of the possible objections to that particular argument. And one of them was questioning the first premise, which was that everything that begins to exist has a cause. And when I first heard of this objection, I kind of dismissed it, thought it was silly, but then I looked into it a little bit more deeply and found that there is actually a pretty substantial argument to be made here. And it spawns from quantum physics, okay? And what's being suggested is that quantum physics has discovered that quantum fluctuations near black holes have actually been or are known or suspected to create atomic particles that pop into and out of existence uncaused, no particular reason or anything for that. They're just coming in and out of existence all the time. And so therefore, if that's true, right, if that's true, then that could, in theory, be the reason how the Big Bang and the entire universe got here. Maybe that was a giant quantum fluctuation. So just imagine, if quantum physics is saying this and this is true, then at the beginning of the universe, you have this just enormous quantum fluctuation that creates everything, this whole entire known universe, and then it expands into the known universe like as we see today. And so that would be the naturalist kind of escape or reasoned argument against there needing to be a God in that equation to create it, because quantum physics says, hey, this is possible. So when I hear this and I started realizing, okay, this is actually a legitimate objection, I started to look into this. And when I attempted to find articles or some type of papers or some type of reliable source, firsthand source that confirmed this, after looking for several hours, I couldn't find anything. And let me just encourage you that if you are looking up at any subject and you're trying to confirm something, and it takes you several hours of searching on Google to find some credible firsthand source that affirms or denies some kind of statement, some kind of truth claim, you're probably looking at a situation where that truth claim has been overstated or it's not quite what it was. Right. Now, that's not to say I didn't find any articles or any kind of posts or something out there that stated these things. There was plenty of opinion articles written by, editorials, stuff like that. I found blog posts. I found social media posts, but those are not firsthand scientific research. Okay, that's just people's opinions. That's people's maybe hearing about this discovery and then turning around and putting their spin on it. So I don't take any of that stuff into account. Likewise, if there's anything that supports anything that I believe that has that same type of grounding, I disregard that as well, because I want to make sure that anything that I'm coming to anyone with and saying, hey, this is true, it's coming from a firsthand scientific, historical, whatever type of resource, and not just somebody's blog or someone's social media post or some writer at some news outlet, however credible or not, that's just writing down their opinion. I don't want that. I don't want opinions. I want facts. Okay. So when I couldn't find it, I'm thinking, okay, I think I may have stumbled upon somebody's opinion. And the more I looked into it, literally, I just couldn't find anything that substantiated the assumption or the claim that quantum fluctuations are actually creating matter or that it is causing matter to pop into or out of existence. I couldn't find it. And I did find an article that I suspect was the cause of this type of theory, this type of line of thinking. And I'll get into that in a second. But what I concluded, and maybe you found this article, a legitimate first-hand scientific resource. And if you have found that, please send it to me. I don't want to share wrong information, as you know. But I couldn't find it after several hours of searching. I felt like that was enough to be able to find something that clear or that substantial. But I want to take a second here to stress that it is never good for anyone to overstate the conclusions of their opinions or what specific research or of any kind is suggesting. So, and I would say to the naturalist who believes that quantum fluctuations are causing matter to pop into or out of existence, that's not what quantum physics has discovered. It's not been substantiated. It's a theory. They think that it might be able to do that, but they have not proven that. And for you to overstate the conclusion by jumping to that and saying, oh, look, it does, it's proven that, it hurts your credibility. Okay, just like it hurts my credibility to try to say that something has proven the existence of God when it hasn't, or something points to the existence of God when it's neutral. Okay, it doesn't help me to do that, right? It just makes me lose my credibility. It makes me lose my trust that you might be willing to place in me. Okay, and a good example of this is COVID. I think the scientific researchers, the doctors that have gone up publicly ever since COVID was a thing, and at the beginning of the pandemic, you heard a lot of doctors and whatnot saying, oh, the science says this and the science says that, and this is what the science is telling us. Well, science doesn't tell you anything. It just has facts and information, and it's up to us to interpret the data and then derive a course of action from that. And what's happened, especially like I said in the early days of the pandemic, is that the people were saying, well, the science says this, and people were, I trust the science, and the science every couple of weeks was changing, right? Because they were deriving different conclusions from the information. And now you see a lot of the doctors and professionals are getting a little bit more careful with how they say things. Based on the evidence and information that we have, we believe the right course of action is to blah, blah, blah. That is what science does for us. It helps us form conclusions and encourage us to make certain decisions based on the evidence. Okay, and so when someone says, well, the science is saying this, and then a couple weeks later the science is saying this, and those two things are different or change slightly, and it ruins credibility. And now what do you have? You have a whole large group of people who are anti-vaccine, they're anti-mask, they're anti-science, they're all this other stuff, and unfortunately, a lot of those people are people of faith. And I, as a Christian, as a believer, a person who believes in God, I see that and I get frustrated because that's my problem, right? That's my house that I've got to try to get in order. And so I would encourage you, as somebody who's a naturalist trying to get your house in order, don't make those claims. If you see people doing that, rein them in, because all it does is hurt credibility. But that going back to what I was saying as far as that article, I found an article that was posted in 2018. It was a joint venture between several different nations, U.S., Israel, and I think one or two others included. I'll put the link in the description of the video so you guys can see it. But what it was a joint effort in the area of quantum physics. And what they found was that as they developed this microscope that was able to operate in near absolute zero temperatures, which is where quantum fluctuations happen, we've developed the ability to look at things at that temperature and recreate those conditions in a lab, because absolute zero does not happen naturally anywhere on Earth. Okay, we have to recreate that. We have to actively make that condition, that temperature, that cold temperature, because it doesn't naturally occur here. As we've been able to do that, we found that there's actually activity at near zero. And what's significant about that is that what we've always thought was that when things are hot, when there's lots of activity, right, over on this end of things, there's a lot of motion, there's heat, there's light, and things are moving. That's what we thought. And as things get colder, it's thought that things get darker, they get colder, they get slower, there's not activity. But that's wrong. What we found is that at these super cold temperatures, there is still activity. And what they found actually was that as they were able to observe these atomic particles, these quantum fluctuations, there's almost like this boiling type of effect at this almost absolute zero temperature, which is super cool. And there's actually a lot of neat implications in quantum technology that might be able to affect our lives here in the next several years, depending on how they're able to develop it. But what was happening is, as they're now beginning to see and observe things at that temperature, they're noticing these quantum fluctuations, and they're able to see particles kind of pop into vision and out of vision, into vision and out of vision. They're not popping into and out of existence, We are now just being able to see movement at that temperature. That's what quantum physics has now recently been able to uncover. Not that particles are popping in and out of existence uncaused out of nothing, right? And you just hear those buzzwords, right? That's what Christians and Muslims and Jews all believe, how God created the universe, that he uncaused out of nothing was able to create time, space, matter, okay? Because we believe that our God is that powerful. He can just create things out of nothing. And that's the same type of verbiage that you're hearing from the naturalists saying, oh, quantum physics is saying that these atomic particles can come in and out of existence uncaused out of nothing. What does that sound like to you? It sounds like rhetoric. It sounds like people trying to push a conclusion, trying to overstate what science has discovered. Again, it does nobody any favors. So again, the discovery is really cool. But when you get into this field and you look at professionals, like evolutionary physicist Victor Stenger, okay, he said this. He said that much is still in the speculative stage, and I must admit that there are yet no empirical or observational tests that can be used to test the idea of an accidental origin. He said this in 1987, and he said this in reference to the Big Bang being caused by a quantum fluctuation. Now, some people might say again, well, hey, I see the date at the bottom. You said it's 1987. That's 35 years ago, Jim. We're in 2022. Things have changed. We've learned more. Yeah, you're right. You're right. But I want to remind you that quantum physics is still largely a theoretical science. We're just now being able to test certain things. Like I said, this experiment in 2018, shows very clearly, hey, there's been some discoveries, and there's going to be some implications in our day-to-day life, which is really cool. But remember what the assertion is that's being made here. At absolute zero temperatures, which does not occur naturally here on Earth, we think that quantum fluctuations can cause particles to pop into and out of existence. Okay, and where we suspect that these occur naturally is near black holes, because that's where you can get near absolute zero, because you have to get really far away from any kind of stellar body to get to absolute zero, because stars and other things in the universe are always causing there to be some type of change, activity, or heat. So there's very few places that you can find absolute zero naturally. So let me ask you this question. From 1987, when Professor Stenger said this, has anything changed in our ability to go to or observe black holes? No. It's still theoretical at that point. Okay, we suspect that quantum fluctuations near black holes can cause particles to pop into and out of existence. Okay, that's fine. We've not been able to observe that yet. Our telescopes are only able to discern light. Okay, and that's it. We can't discern temperature. We can't view things close up. Now, light can tell us a lot, and that's great. And the more powerful our telescopes are, the more we learn, absolutely. But we are not able to detect or learn anything at that level, not yet. We'd need to be able to travel near a black hole. We don't have that ability yet. Our ability has changed zero since 1987 to today to be able to do that. So I want to put things into perspective and remind you of that. And I also want to point out that even if this turns out to be true, that in the natural universe, that quantum fluctuations can cause particles to pop into and out of existence, atomic particles, near a black hole, that is a far, far, far cry away from a quantum fluctuation on the magnitude of the universal scale of causing everything to pop into existence, uncaused out of nothing. You're talking about two wildly different things, okay? And to say that, well, if that's possible, then why not? Why not this? You're talking two way different ends of the spectrum, okay? It's like if I tell you, hey, I got a royal flush, that's kind of remarkable. And I say I got royal flushes twice in a row. Wow, that's pretty significant. That's rare. Everybody would agree on that. But if I told you I got 20 royal flushes in a row, that's a whole nother monster than saying I got 2 royal flushes in a row. Whole nother monster. And I believe you would agree with that. And that's the scale that we're talking about. We're talking about an atomic particle versus all of existence, the entire universe. But ultimately, I think what lands me on the side of saying that that is likely not going to be found to be true, that atomic particles do in fact pop into and out of existence, is based on confirmed science. Okay, so if we look at the first law of thermodynamics, or the law of conservation of energy, it states that the total energy of any isolated system for which energy and matter transfer through the system boundary are not possible, just to put that in more simple terms, it means that energy cannot create matter, okay, that is constant. Energy can be transformed from one form to another, but can neither be created nor destroyed. This is the first law of thermodynamics. This is agreed upon science. This is confirmed, verified scientific law, not theory, like quantum physics is theorizing here. Scientific law states that energy and matter can never be created or destroyed. They can simply be converted, okay? Converted from one state to another. Let's put it to this example. I can take two combustible elements and set fire, a chemical reaction, to a tree, okay, and burn that tree down. And when the tree's done burning and it's gone, it'll be a pile of ash, okay? It could be 100 feet tall, doesn't matter. It'll just be a pile of ash at the end, when it's done. And the rest of that tree, you'll see maybe this pile of ash, but that's it. It's nowhere near this 100-foot tall tree. So what happened, some people might say, oh, the tree's been destroyed. No, it's not. It's been converted to ash, and any of the liquid matter, anything that could have been changed into a gas, has been converted to a gas and dispersed in our atmosphere. That tree's not been destroyed. It's been changed, okay? So matter, energy, they're never destroyed. And this is, again, agreed upon, verified scientific law, okay? This is different from theory. This is what we know to be true and what we can observe and repeat in our universe, okay? For particles to pop into and out of existence uncaused, out of nothing, you're talking about literally violating the first law of thermodynamics. So as a naturalist, you would have to, as an example, explain why 1 + 1 = 2, but not all the time. See, it doesn't make sense. Now, what what quantum physics is discovering and innovating is groundbreaking. It's amazing. It's really cool. And as a science fan myself, I look forward to seeing what this field of science is able to discover in the years to come. But the last thing that anyone wants to do is overstate or exaggerate the conclusions of any kind of claim or statement or discovery. It hurts everyone. It hurts truth. We don't want that. We just want to believe things are true. Whether you believe in God or not, you want to believe in things that are true, just like I do. So it doesn't do anyone any favors to exaggerate that claim. So again, I would say if you're able to find a more legitimate first-hand scientific article where the scientists are stating that they have been able to confirm that and give that to me, I would welcome you to send that my way. I want to hear it, want to see it. But until then, I think we can pretty safely and reliably land on the fact that things do not pop into and out of existence uncaused, out of nothing. Science says that, and I'll stick with the science. Hope you guys enjoyed this episode. Love to hear your feedback. Don't forget to like, comment, share, and subscribe to the channel. Love to hear your feedback on any video that I have and engage with you and hear your thoughts. Have a great day, everyone. God bless.